All right, welcome everybody. Today we're going to talk about lesson number 61, and this is the third day of 5.3, solving trig equations. Today we're going to focus on first values that you need to find using the calculator as opposed to using the unit circle, and then finally something called functions of multiple angles, which means instead of having just a 1x inside of the trig function, you will have some other angle. So here to start, we're going to go ahead and focus on finding the solutions from 0 to 2 pi, and we're going to use the calculator to solve as needed. Now, again, just because I'm bringing the option in that you can use a calculator to solve doesn't mean that you're going to need to for every problem. So going forward, that's a new question you have to ask yourself. Do I need the calculator, or is it a unit circle value? Here in number 1, when they're asking you to solve, where does the sine of x equal 1/8? If you were to look at your unit circle, if you were to look at all your ordered pairs and all of your y values, no matter how far you look, you will not find any signs that are equal to 1/8. 1/8 is a value inside of the range between -1 and 1, though, so I know there is a solution. In order to find that solution, I have to get rid of the sign. And of course, hopefully you remember back from lesson 46, the way you get rid of a sign is by taking an inverse sign of 1/8. Make sure that your calculator is in radian mode. And again, I know that it should be in radian mode because 0 to 2 pi implies radians. So when I go ahead and do the inverse sign, which again is second sine of 1/8, I'm going to get something in the calculator, which may or may not be a solution. If it's not one of the solutions, I will need to use it to find the solutions. And you're going to go ahead and round to 3 decimal places unless it says otherwise. So the inverse sign of 1/8, that is going to give you an answer of 0.125. And then you have to think about your unit circle. Even though you're not on it, the signs are y values, which are positive in quadrants 1 and 2. So the answer that you found was the quadrant 1 answer, 0.125. Signs are also positive in the second quadrant. And then again, hopefully you remember the whole point of reference angles, remembers, is that whatever this angle, 0.125 is, you're going to have the same reference angle over here in the second quadrant, 0.125. If you want to find what this angle is, you would have to take the closest x-axis, which in this case would be pi, and you would have to subtract 0.125. If you go ahead and do that using the calculator, you are going to get an answer of 3.017, and that is going to be your second answer. Again, because they're saying to solve from 0 to 2 pi, that means only once around the circle, which means you have an answer in quadrant 1, you have an answer in quadrant 2, and that's it. A very quick, easy way for you to check is to go back to your calculator, take the sign of 0.125, and you should get 1/8. Take the sign of 3.017, and you should also get 1/8. So again, that's a quick, easy way for you to check that you are doing this right. I kept all these equations very simple here to start, just to remind you of how to use the calculator. So here in number 2, the cosine of x equals -1/6. Again, try as you might on your unit circle, you're not going to find any cosines, which means any x values that are equal to -1/6. So the way that you get rid of the cosine is by taking the inverse cosine. The inverse cosine of -1/6, again, gives you an answer. The answer in this case turns out to be 1.738. Again, that may or may not be an answer. It depends on your unit circle. So 1.738, that is an answer in the second quadrant. And again, just as a reminder, this has a decimal approximation of 0. This is pi, which is 3.14. All the way around would be 6.28. Pi over 2 would be 1.57, and 3 pi over 2 would be 4.71. Those are those decimal radians that, again, we did a whole bunch of practice with back in chapter 4. So if you're having any trouble remembering, simply go back and refresh. So cosines, remember cosines are the x values, which means there has to be an answer in quadrant 2, and there has to be an answer in quadrant 3. So it looks like I have found the quadrant 2 answer, and that is half my solution. In order to find the quadrant 3 answer, I have to find the reference angle. So the reference angle, again, we denote with theta prime. That means theta reference angle. If you want to find that angle right there, you have to take the entire angle, which was 1.738, and you have to go ahead and subtract it from pi. So pi minus 1.738, that is going to give you the reference angle. And the reference angle in this case is 1 0.404. If you now want to find this third quadrant angle, you have to add it to the closest x-axis, which is pi. And if you go ahead and do pi plus 1.404, you're going to get your second answer of 4.546. I'll go ahead and write that over here so everything is next to each other. And again, this is my answer in quadrant 2. This is my answer in quadrant 3. If I take the cosine of each of those values, I should get approximately negative 1/6. And again, the reason why that I know it's quadrants 2 and 3 is because of the fact that cosines are x values. And so that's how I know that it's quadrants 2 and 3 where they're negative. Here for number 3, the sine of x equals negative 1/4. Again, look at your circle. There are no y values equal to negative 1/4. So that's how I know it's a calculator situation. So I'm going to do the inverse sine of negative 1/4. If I go ahead and do that, that is going to give me an answer of negative 0.253. So if you think about your circle, negative 2.53, that's an angle here in the fourth quadrant. Hopefully you can remember, again, back from lesson 46, if you get a negative acute angle out of the calculator, which this is, the reference angle is always the positive version of this, which would be positive 2.53. So that's going to help me. If I'm talking about sines being negative, I'm going to need an answer in quadrant 3 and in quadrant 4. So again, the answer that came out of the calculator, negative 0.253, technically that is in quadrant 4, but because I'm trying to solve this from 0 to 2 pi, that answer is not in that interval. So again, if the reference angle is 0.253, that's this right here. If I want to find this entire angle, I'm going to go ahead and subtract 2 pi minus 0.253. And if I go ahead and do that, I'm going to get a quadrant 4 answer of 6.030. Then I have to do a similar exercise here in quadrant 3. So in quadrant 3, again, it has the same reference angle. In order to find this blue angle, I would have to do pi plus 0.253, and that would give me my answer in the third quadrant, which would be 3.395. Again, only 2 answers because there's only 2 quadrants where y values are negative, and I'm only going once around the circle. If you're wondering, well, can I solve these kinds of problems for the general solution? Absolutely. Same idea. The answer just looks a little bit different. So let's go ahead and try that here in number 4. So find the general solution, and again, use the calculator to solve. And using the calculator, again, doesn't have to be a guarantee from this point forward. It just is an option. So taking a look at this problem, it looks like there's an awful lot going on here. So I'm going to need to go ahead and try to do something first to get it in a little bit of a friendlier format. So I'm going to go ahead and start by rewriting the secant as 1 over cosine. And I'm actually going to leave everything else the way that it is. If I take a look at this 1 over cosine times a sine, hopefully you recognize that that is a sine over a cosine, which actually means a tangent. I now have a bunch of tangents, which I can add together. So 5 times the tangent of x would be equal to 30. If I go ahead and divide by 5, I'm going to get that the tangent of x is equal to positive 6. Now, remember, there is no restriction on the range of the tangent. So the fact that it's 6 is perfectly fine, but it is not, however, one of my unit circle values, which means I am going to need the calculator. So I'm going to go ahead and do the inverse tangent of 6. If I go ahead and do that, the answer that comes out of my calculator is going to be 1.406. So think about your unit circle. Think about 1.406. That is a value in quadrant 1. Think about what other quadrant has a positive tangent. That would be over here in quadrant 3. Because I'm trying to give the general solution, I want to figure out, is it the same distance from the 1.406 to the third quadrant, and is it the same answer back? And it is. Remember, whenever it's quadrants 1 and 3 or 2 and 4, it's equidistant. So my answer here for the general solution is if I start at 1.406 and then I simply keep going around multiples of pi n. That's going to give me all my answers. And yes, you can still use pi n or 2 pi n or pi over 2n. Just because you need a decimal for the 1.406 doesn't mean you have to worry about the decimal for the pi values. So hopefully those 4 examples help to refresh you on how you're going to use the calculator. Again, this was something that most of you did struggle with the first time around. So if you do have questions, now would be the time to ask, or certainly you can go back to lesson 46 to assist you. And then the last part of today's lesson involves something called multiple angles. So multiple angles means that inside of your trig function, you're going to have the sign of something times u, which we're going to call k. So sine of ku, cos of ku, or tan of ku. Please be advised that for problems like this, we're only going to be asked to do the general solution. It's not that you can't do 0 to 2 pi, but it actually winds up being just a little bit too down in the details. So we're going to go ahead and stick to the general solution only. Here is the general idea, though, of how you're going to go ahead and do that. You're first going to solve for ku, just like we've done this whole time. Then you're going to divide whatever your result is by whatever the k is. And again, the k is always what's in front of the x. So here, take a look. We have 2 times the cosine of 3x minus 1. So the first thing you might want to identify is here is what is new. This cosine of 3x, that 3x is sacred. Up until this point, we've only ever seen the cosine of 1x or the sine of 1x. You never even really noticed it before because it was always just an x. Now you have to be on the lookout for when is it something bigger than x. So I'm going to go ahead and take a look at that 3x, and it's sacred. I'm going to leave it there until I'm ready for it. I'm going to go ahead and first start by just doing some algebra. So I'm going to take the cosine of 3x, and I'm going to add the 1, and then I'm going to divide by 2. So I'm going to start now by solving this problem the same way that I normally would if this was just the cosine of x equaling 1/2. So think about your unit circle. Think about cosines equaling positive 1/2. Well, that would be in quadrant 1 and quadrant 4. Think about what family that would be. That family would be the pi over 3 family. So actually that would be these families. So pi over 3 and 5 pi over 3 would be your 2 values, one trip around the circle that had a cosine of 1/2. Normally, when you go to set this up, you would say that your answer was equal to pi over 3 plus 2 pi n, because you'd have to go all the way around the circle to get back to pi over 3. Then you'd have to set up a second equation for 5 pi over 3 plus 2 pi n. And again, as a reminder, they each need their own because the distance from one to the next is not the same as the distance back. But the difference here is instead of setting x equals, you're going to set 3x equals. So whatever happens to be inside of that function. So first you're going to solve for ku, which we've done, and then you're going to divide your answer by k. So you have to take everything in this first set of answers and divide it by 3. You then have to take everything in this second set of answers and divide it by 3. So to get to your final answer for the first one, you're going to divide by 3. So pi over 3 divided by 3, you're going to multiply the denominator to get pi over 9 plus 2 pi n divided by 3 is going to be 2 pi over 3n, and that's going to go ahead and give you the answer for the first equation. Then here for the second one, again, if you divide by 3, 5 pi over 3 divided by 3, you're going to multiply the denominator, which gives you 5 pi over 9. And then 2 pi n divided by 3 gives you 2 pi over 3n. And those are now going to be your 2 equations that are going to go ahead and solve this multiple angle problem for you. So again, very similar idea. You're going to solve just like you did for the past couple of lessons, except now whatever is in front of that x, you have to divide it away in order to transform your answers. Feel free to pick values of n, plug them in, go back to the original equation and check it. And I promise, whatever you get there, you will get a cosine of 1/2. But again, this is kind of just something you can do if you have extra time. Let's take a look here at number 6. So 3 times the tangent of x over 2 plus 3. And again, the difference here is the fact that it's x over 2. So you're going to disregard that for a minute, and you're going to solve just like you normally would. So the tangent of x over 2, you would subtract the 3 and then divide by 3, which is going to give you the tangent of x over 2 equals -1. -1, we're back on the unit circle. Tangents are negative in quadrant 2 and 4. It's the pi over 4 family. So this would be 3 pi over 4 and 7 pi over 4. Notice that because it's quadrants 2 and 4, it's the same distance from one to the other as it is back, which means you can write your answer as 3 pi over 4 plus pi n. The difference here is instead of saying x equals, you're going to say x over 2 equals. Remember the rules from the previous problem. In order to now change it to the final answer, you would divide by a half. The reason why it's a half, because this is really 1/2 x. So you're going to divide by a half, and then obviously an easier way of dividing by a half is multiplying by 2. So I actually recommend you do the second. So if I go ahead and multiply everything by 2, I'm going to get x equals. So 3 pi over 4 times 2, that's going to give me 6 pi over 4, which becomes 3 pi over 2. And then instead of pi n, it's going to give me 2 pi n. So again, you're going to have to now, if you have questions, ask. Certainly, it's a little bit more work. Certainly, it seems a little strange perhaps, but it's just one additional step that you now have to perform. And finally, let's take a look here at number 7. So the cotangent squared of 3x equals 1. So again, let's go ahead and focus in on where the multiple angle is. That would be the 3x. Cotangents are okay, but we're bigger fans of tangents. So this is really 1 over tangent squared of 3x equals 1. And then I'm going to flip both sides. So tangent squared of 3x, if you flip the left side, and then if you flip the right side, you happen to just get 1 again. So now to get rid of the squared, you're going to take the square root. Don't forget when you take the square root, you have to do plus or minus. So we're down to the tangent of 3x equals plus or minus 1. Think about your unit circle. Think about the fact that it's plus or minus means it's all 4 quadrants. Think about what family it is. What family has a tangent of 1? That's the pi over 4 family. And in this case, because of the fact that it's all 4 quadrants and it's pi over 4, you can actually write all your answers with just one interval. So we're going to say 3x is equal to, the first answer is pi over 4 plus, and then an interesting thing, only in this particular case. So again, this is only for the pi over 4 family when it's all 4 quadrants. The distance from pi over 4 to 3 pi over 4 is the same as the distance from 3 pi over 4 to 5 pi over 4, 5 pi over 4 to 7 pi over 4, and 7 pi over 4 back. It's always a distance of pi over 2 between each of those red lines. So again, if you have the pi over 4 family, all 4 quadrants, you can write just one equation, which would be pi over 4 plus pi over 2n. To finish this, you're going to have to divide everything by 3. So x equals pi over 4 divided by 3, multiply the denominators to be pi over 12, plus pi over 2n, multiply the denominator to be pi over 6n. And that is actually going to incorporate all of the solutions for you, all 4 quadrants, all the way around. And again, you're only allowed to write this single equation, again, because it's the pi over 4 family and all 4 quadrants. That's the only time that you're going to be able to do that. So again, that kind of finishes up section 5.3. Whilst we do these new topics of bringing back the calculator and using the multiple angles, you're still just reviewing the general techniques from 5.3. So thanks very much for tuning in, guys, and we will catch you next time.